The National Electrical Code, specifically in Appendix D1, provides examples for calculating electrical loads. When determining the neutral conductor size, understanding how different appliance loads are considered is important. The use of 10 amps for both the dishwasher and the air conditioner in the example is based on typical current draw and serves as a practical and conservative estimate. A standard dishwasher might draw between 5 and 8 amps during its operation. An air conditioner's current draw can vary more widely, ranging from 5 to 15 amps or even higher, depending on its cooling capacity and efficiency. Therefore, using 10 amps for each appliance provides a reasonable buffer, ensuring that the neutral conductor has sufficient capacity for the anticipated load. The neutral conductor carries the unbalanced current in a circuit. If the actual current draw is higher than expected, an undersized neutral conductor could overheat, potentially causing damage or creating a safety hazard. Using a slightly higher estimated current draw helps to mitigate this risk. Now, let's address the application of the values 3, 2, and 2, which represent 25% of the largest motor load. These values are not directly related to the horsepower of specific appliances like dishwashers, but are part of a simplified calculation method used in the NEC to account for motor loads and dwelling units. The 3 amps, 2 amps, 2 amps sequence is based on a method of estimating motor contribution to neutral load. Firstly, the 3 amps is representative of the largest motor's contribution. Secondly, the first 2 amps is representative of the next largest motor or motors, if their total horsepower is at least 50% of the largest motor. Thirdly, the second 2 amps is representative of any additional horsepower of the next largest motor or motors if their total horsepower is less than 50% of the largest motor. These values are guidelines for estimating motor contributions to the neutral load. This method simplifies calculations by providing fixed values based on the relative sizes of motors, rather than requiring precise measurements of each motor's actual running current. When determining which appliance constitutes the largest motor, you need to consider the appliance with the highest motor horsepower rating, or the appliance that draws the most current during operation. While a waste disposer can draw a significant amount of current, up to 10 amps, it's not automatically considered the largest motor in every situation. Other appliances, such as refrigerators or even certain types of washing machines, might have motors with higher horsepower ratings or higher current draws. The specific appliance considered the largest motor can vary depending on the appliances installed in the dwelling unit. In example D1, the dishwasher is assumed to be the largest motor because it has the highest connected load, which is 8.5 amps. This assumption simplifies the calculation for the example. However, in a real-world scenario, it's important to verify the actual current draw or horsepower rating of each appliance to determine the largest motor accurately. To accurately size the neutral conductor, you must consider all the loads connected to the circuit, including lighting, appliances, and motor loads. The total neutral load is the sum of the individual loads adjusted for any applicable demand factors or diversity factors as permitted by the NEC. In a specific scenario of example D1, the neutral conductor sizing is calculated as follows. Firstly, the appliance loads, including the dishwasher, air conditioner, oven, range, and lighting, contribute a total of 60 amps. Secondly, 25% of the largest motor, which is the waste disposer, contributes 3 amps. Therefore, the total calculated neutral load is 63 amps. If the calculated neutral load exceeds the ampacity of the initially selected neutral conductor, a larger conductor must be chosen. In this case, since 63 amps exceeds the 60 amp ampacity of the initial conductor, a larger neutral conductor with an ampacity of at least 70 or 75 amps would be required, depending on the available standard conductor sizes and the applicable ampacity tables in the NEC. In summary, determining the appropriate size of the neutral conductor involves carefully considering the loads connected to the circuit, including appliance loads, motor loads, and lighting loads. Using conservative estimates for appliance loads and applying the appropriate factors for motor loads helps ensure that the neutral conductor is adequately sized to handle the anticipated current, minimizing the risk of overheating or other electrical hazards. When dealing with electrical calculations and conductor sizing, always consult the latest edition of the National Electrical Code and follow the guidelines and requirements specified in the code. Also, it is recommended that one seek the services of a qualified electrician.